This video provides an overview of the tool called C3TRACE. C3TRACE stands for Command, Control, and Communication, Techniques for Reliable Assessment of Concept Execution. C3TRACE is owned by the U.S. Army Research Laboratory and developed by Alion Science and Technology. It is a human performance modeling tool that focuses on operator workload and how information flow impacts decision quality. It uses stochastic discrete event simulation to model the range of tasks or activities performed by operators. C3TRACE has some unique features. The first is that personnel are defined and assigned to organizational sections. Second, there is no limit to the number of sections, subsections, or personnel. It also includes a built-in information-driven decision quality algorithm that tracks information elements as they are communicated from person to person. It has an embedded workload algorithm to predict operator mental workload demands. It models dynamic operator assignment, and it allows users to define their own performance-shaping factors that impact task performance. There are three main elements to every C3TRACE model that must be defined. The first is personnel. Who are the operators that perform tasks, receive information, and distribute information? The second is defining the functions and tasks that are performed to accomplish a mission. The third element is called communications. What are the communication events that drive the flow of information? C3TRACE is a Windows application and therefore has many familiar features. The main components are the toolbar, the menu bar, the task network window, model components tree view, and output window. C3TRACE does feature a user customizable environment so you can rearrange and open and close windows as desired. Let's go to C3TRACE and look at the application. This is C3TRACE. You will see a title bar, a menu bar with familiar things like a file menu for creating new models, opening models, saving models, printing and exiting the application, the edit menu for familiar things like cut, copy, paste, as well as search and replace. The view menu allows you to edit the zoom level, select a window to open, or reset the layout. The define menu guides you through the different available options for data entry. The execution menu is used for running your model. Of course, you access the reports via the reports menu. The utilities menu has network and export options. The C3Talk menu option allows multiple C3TRACE models to communicate with each other. And finally, the help menu allows you to access the online help and sample models. The toolbar, right below the menu bar, has commonly used controls for quick action. Standard icons for new open, save, cut, copy, paste, and model execution are found here. The Model Components window is a tree view where you can see all elements of your model. You will use this for adding and deleting elements and for opening description windows. The output window down at the bottom is where messages will appear. Any errors as well as execution details will be displayed here. There are 6 steps for building an analysis using C3TRACE. Step 1, define the personnel. Step 2, define the functions and tasks. Step 3, define the communication events. Optional Step 4, define the shaping factors. Step 5, execute. Step 6, analyze results. Defining personnel in C3TRACE involves specifying the sections, subsections, and operators in the analysis. Let's go back to C3TRACE. In the Model Components window, you'll see a node labeled Personnel. In a new model, there's nothing below that, so it's blank. However, if I right-click on that node, I get options for adding sections and personnel, as well as cut, copy, and paste. If I select Add Section, it's going to create a section node below my Personnel node. I can continue to add another section. I can click on a section, right-click on there, and add an operator. And I can continue to do so until I've added all of my operators and sections that define my organization. If I double-click on a section, it opens a description window for that. The only parameters of a section are its name and its ID, and I can edit those from the description window here. If I expand that over here and double-click on an operator, then that opens the operator description window. There are 4 tabs for operator definition. The first tab is Attributes. From here you can set the operator name, ID, maximum time a task can be interrupted before it's dropped, and attributes such as MOS, training, length of service, etc. You can also set a workload threshold for each operator. The next tab is called Operator Assignment. If we'd had any tasks defined and assigned to this operator, you could quickly see what tasks this operator has been assigned to. The next tab is Schedule. This data allows you to simulate the operator leaving or becoming unavailable during the simulation. You need to check the box that says the operator will leave and enter what time the operator will leave, simulation time. So I can say this one will leave 10 minutes into the simulation. When he will return, or if he will never return, I click the box there. The last tab is Notes. From here, you can enter any assumptions or notes about the operator. Another feature that C3TRACE has is the ability for users to create personnel groups. This is a way to define a group of operators that can perform a task or tasks together. Within C3TRACE in the Model Components view, again, there's a Personnel Groups node. Right-clicking on there allows me to add the group. If I double-click on that new group, it opens the description window, and I can see the sections, and I can expand those, and then I can pick which operators are members of my group, so they can be within different sections. And there we are. By simply clicking the boxes, I assign who's in the group, and then I can also rename that group as something else. The next step is to define the functions and tasks. In C3TRACE, only functions are defined at the top level of the network diagram. Functions can be thought of as being containers for tasks. Functions are also represented by a node in the Model Components view. Double-clicking on the node brings up the Task Network window. From here, you will graphically define the functions in your model by right-clicking in the diagram and picking Add Function. You can add multiple functions here and connect them by drawing paths between them. So you just take the arrow there and draw it between them. Double-clicking on any function will open a new network diagram window for you to define the tasks and or sub-functions. From here, if you right-click, you will see that you now have the option to add a task. Add tasks and paths the same way that you added functions. So you can just quickly, graphically draw your network diagram and create paths between them. The numbering of each task indicates thy level of hierarchy. The 1 shows me that these tasks belong in function 1, and the last number shows me it's task number 3. Function properties are its name, ID, and appearance. To edit the function properties, right-click on the function name over in the Model Components view and say Edit Function Properties. The function description window will open up and let you change any properties there. Tasks are the building blocks of any C3TRACE model and therefore have many properties. To open a task description window, simply double-click on a task in the network diagram. At the top, you can enter a name for the task and see its item ID, the last number. Below are there are 10 tabs used to define the function task properties. The first one is labeled Description. This is where you specify situational awareness types, modes, priority, and mark as a collaborative or decision task. The second tab is Timing. This is where you enter time parameters. You can select one of 22 different distributions and enter relevant parameters based on the distribution selected. The third tab is Assignment. There are 4 primary task assignment options. First is assigning to primary and supporting operators. The next one is assigned to anybody in the section. The third is assigned to a personnel group. And the fourth is to mark the task as automated. Depending on what option is selected, the fields below become active or inactive. The next tab is the Effects tab. From here, you enter code to make your model behave in the manner desired. You use C# expressions in each of the fields shown on this tab. The fifth tab is the Workload tab. To specify the workload imposed by a task, you specify the visual, auditory, cognitive, psychomotor load using the benchmarks in the drop-down. And then you also mark the perceptual, cognitive, and resource modalities using the checkboxes below. If you hover over it, you can get a definition of those. The next tab is the Weightings tab. The values here are only editable if this is marked as a decision task, back on the Description tab. So if I go back here to the description, mark it as a decision task, go back to my weightings, these are now active. From here, I can tell C3TRACE what information elements are used to make the decision and rank them by how important they are on a scale from 1 to 10. There are course of action elements built in, as well as PMESI elements, or you can define your own. The next tab is labeled Consequences. Once again, the data here is only active if this task is a decision task. Making a bad decision can have consequences on the execution of the model. It can either have no effect, change the timing on another task, or trigger a communication event. You can specify the percentage of times that each option is chosen here. The Paths tab is used to tell C3TRACE what task will follow this one and under what conditions. There are 5 types of branching decisions. Multiple means execute all following tasks that evaluate to true. Probabilistic, only one following task will be chosen based on the probabilities. Tactical, only one following task will be chosen based on an expression or variable value. The one that evaluates to the highest will execute. Communication-based tactical means the path will execute based on the communication type. Or decision quality based, where the path will execute based on the decision quality, good or bad. The Queue tab is next. When an entity must wait to be processed, often because of limited resource, it can go into a queue. Sometimes the behavior of a queue is important. The different types of queues that we have are none, FIFO, which means first in, first out, so this would be like waiting in a bank line. LIFO, last in, first out, something like stocked shelves. Or based on some priority that you define, like an ER would be an example. You can specify the queue type and enter expressions for what happens when the queue is entered or departed. The last tab is Appearance and Notes. By default, C3TRACE makes regular tasks oval and blanched almond in color. Decision tasks are octagon and light steel blue colored, and collaboration tasks are yellow octagons. You can override the shape and color as well as set the font and enter notes on each tab. Communications are events that carry information and can get passed from operator to operator. Each C3TRACE model must contain at least one communication event. In C3TRACE, there's a communications node in the model components tree. Just like the other elements, you define the communication events from here. To add a new communication event, right-click on the node and select Add Communication. A new event will be created below. Double-click on the event to open the description window. And from here you can give the communication a name and a set of parameters. There are 3 tabs in the windows. The first is parameters. From here you set the type with your choices of digital, face-to-face, voice, written, haptic, radio, or intercom. You can set the initial information quality from 0 to 100. This is an indication of how good the information is when it's first received. Information coming from a very staticky radio might be lower than a clear digital communication. You can then set the trigger type to either time or task. A time trigger means that the event will occur at a specific time, and a task trigger means that the communication will occur whenever a specific task executes. You can also specify who the event originated with. The fields below are active or inactive depending on the trigger type. If it's a time trigger, you need to specify the time parameters, and if it's a task trigger, you need to specify what task it's coming from. The next tab is the information elements. From here you specify what information is included in the communication. There are course of action and political, military, economic, social, information or infrastructure or PROMESI elements built in, or you can define your own. To indicate the information contained, simply click the check boxes. So if my communication contains information on enemy who, what, and when, I would specify those boxes. The third tab is named Trigger. This is where you specify what task or tasks are triggered by this communication event. You click the Add button and then select a task from the displayed Task ID drop-down. And each communication event can trigger 0 or more tasks. The personnel, functions and tasks, and communications are the main pieces of any C3TRACE model. I'm now going to go over how these elements and parameters are used to calculate workload and decision quality by C3TRACE. C3TRACE can be used to help analysts predict whether the workload imposed by multiple tasks will overload the operator and cause the task to be dropped, delayed, or performed in a degraded manner. It uses the task demand load, as represented by the sensory, cognitive, and psychomotor demands associated with each task, and the interference imposed by performing multiple tasks simultaneously. The workload theory embedded in C3TRACE assumes that every task places demands on the operator and that the demands can occur across multiple resources. For example, consider a task like steering a car. This involves visual work, watching where you're going, cognitive work, deciding if you are turning enough and whether to slow down or speed up, and psychomotor work, rotating the steering wheel. These can each complement each other or cause interference. In addition to just knowing what resources are used, we also assign a number between 0 and 7 to indicate the degree the resource is used. To help assign the degree, C3TRACE uses benchmark scales with descriptors of each resource demand. For example, the cognitive demand ranges from 0, no demand, to 7, estimation, calculation, conversion. There are scales for each of the resources: visual, auditory, cognitive, and psychomotor, or commonly referred to VACP. In C3TRACE, workload can be used to predict if multiple tasks can be performed simultaneously, or if the operator will become overloaded, thus causing tasks to be delayed or dropped. C3TRACE sums all the demands across the resources for all active tasks and adds the sum of resource interference from the conflict matrix to calculate a total workload score. The conflict matrix is universal for all tasks in the model. A default matrix is provided, but you can edit it as desired. Each cell in the conflict matrix can have a value between 0 and 1. 0 means no interference, and 1 means total interference, or the task cannot be performed at the same time. As an example of total interference would be two tasks that both require speaking. They cannot both be performed at the same time. Now I will go over the information-driven decision algorithm embedded in C3TRACE. The general idea is that information is collected in processing tasks, shared in collaboration tasks, and used in decision-making tasks. Under the covers, C3TRACE keeps track of who knew what and when by tracking information elements as they flow through the model. Another factor involved is the volatility of information. Does it degrade over time or remain stable? For example, you would expect that information about where an enemy moving troop is would be more volatile than the location of a building. C3TRACE takes that into account. The algorithm used to determine the quality of each information element at any point in time is information quality equals the initial information quality minus the decay rate time since update times the weight. Whenever a decision needs to be made, C3TRACE calculates a decision quality score by normalizing the information quality of all elements needed to make decisions. Once you've defined the personnel, tasks, and communication, it's time to run the model and view results. Before running the model, it's always a good idea to check the execution settings. We're going to go to C3TRACE and I'll show you how to do that. To open the execution settings window, I just double-click on it from the model components view. Here you can set the number of runs, random number seed, and various other settings. Next, check the model for error. When you check for errors, C3TRACE checks that the analysis has at least one function defined, all functions are decomposed, all tasks are assigned, all tasks have time expressions, and it also checks the model syntax. Any errors are reported in the output window. Now we're ready to run a model in C3TRACE. I have a model open that I developed that looks at technical support operations where we have questions coming in via email, face-to-face, phone, or fax. First of all, I'm going to check for errors by clicking the little check mark on the toolbar. It tells me there's no errors found and my simulation was successfully created. So now I'll go back up to my toolbar and click the Begin Simulation. And then on the output window I can see what tasks are executing, I can see how long that ran, and I can also see a clock at the bottom that updates it's running. Once it's done, I get a simulation complete message in the output window, and my model is finished running. Results in C3TRACE are in the form of either tabular or graphical reports. Reports can be grouped into categories of operator performance, other operator data, sensor to shooter time, communication, and task data. We're now going to go look at some sample reports. You can view any report by selecting it under the Reports menu. Graphical reports are indicated by the pie chart, and tabular reports are indicated by the grid icons. If I select Operator Utilization, I can see that it's going to be a graphical chart, and I can see that all of my operators had almost 100% utilization. Let's look at the Operator Workload Report. That's another graphical one. I can select an operator down here, and it'll show me what their total workload was as well as for each component over time as the model ran. I select the operator using the little drop down at the bottom. An example of a tabular report would be the operator activity report. So this shows me over time what operator was doing what task, what time each one started and ended, and the duration. If I click on, let's say, the operator column, it's going to sort the results by that operator, so I can go down and see that my tech support operator 1 read an email, then researched a solution, wrote an email back. So it's showing all tasks that executed as the model did. So you can see that there's a lot of different reports that you can choose to look at, and those will all help you figure out what the workload and task activities were for your model. A filed version of the user's manual is installed with C3TRACE. There is also online help access under the help menu, and sample models that can be accessed from there as well. Thank you very much for taking the time to view this video. If you have any questions or comments, my address and email are shown below. Happy modeling!